So today our focus is going to be on being able to describe a real world situation by writing inequalities. So first thing I'm going to tell you is what inequality is. So an inequality is a mathematical sentence. And when we talk about inequalities, up until this point, we have been talking about equations that are balanced. An inequality is going to be a mathematical statement that shows an imbalance. So it's showing things that are sometimes not equal, but occasionally can be equal. So an inequality is a mathematical sentence that's going to have less than, greater than, equal to, or is not equal to. It also can have less than or less than or equal to, or greater than or equal to. So remember that this line right here represents equal to. Okay? So what this means when I have an inequality that is going to be equal to, it means that the value that I have can be equal to the other value. I know that's a little vague right now, but I think it'll make sense the first time I pull up a problem. So if you have something that looks like this, so it says, notice, children under the age of 8 must be accompanied by an adult. So I have children under the age of 8 must have an adult. Okay, so that's a real world situation. We see this all the time. We see it at amusement parks. We see it on different rides. We see it, in this case, going sledding. You need to have an adult accompaniment. Movies, the different movie ratings saying, hey, you really should have a parent. If it's a PG-13 movie, or if it's a rated R movie, that's a situation where you have to be 17 or older or have that parent with you. So the first question I'm going to have is, what ages can I have for children under the age of 8? So I could have 7, I could have 6, 5, 4, 3, 2, 1, and I could have an infant. So those are the ages that I can have that are going to be children. Now, I don't want to have to write an inequality for everyone. I don't want to have to write 7 is less than 8, 6 is less than 8, 5 is less than 8. That's going to be very repetitive. So what I can do is, when I have my multiple values like I have here, is I can use a variable to represent multiple values. So I'm going to use the variable of a. So a can represent, again, variable represents an unknown quantity. A can represent multiple solutions in an inequality because, again, an inequality is going to be something that is not balanced. It's an imbalance. So I don't have to have something that exactly lines up. So what I'm going to write as an inequality is I'm going to say a is less than 8. Now, my solution for a can be 7, 6, 5, 4, 3, 2, 1. Any one of these values I can substitute in for a and make this inequality true. Okay, so if I have a different situation, so let's say that I'm on the convince me under the bottom of page 114. It says, show some of the ages of people who do not need to be accompanied by an adult on a number line. Let n equal the ages of people who do not need to be accompanied by an adult, and write an inequality to represent the students' ages. So if I draw a number line to show this, okay, we'll say this is 8, and then I have 9, 10, 11, 12, 13, 14. I'm going to do 7 here, 6 here, 5 there, and then I'll do 15. So I'll do 10 quantities. So there's my number line. What this problem is asking me to do is asking me to show on the number line the values that would represent the children who do not need to be accompanied by an adult. So if I'm under the age of 8, I absolutely have to be accompanied by an adult. That's what the rule says. So I'm looking for the opposite. So if I'm 8 years old, I don't need an adult. If I'm 9 years old, I don't need an adult. If I'm 10 years old, I don't need an adult. 11, 12, 13, 14, 15. I could keep going. So because my numbers go on infinitely, I could have an infinite number of solutions. So I want to show that by writing an inequality. So what I'm going to write is I'm going to take my variable, and when I write an inequality, I always want the variable on the left side. It'll make it easier when we start to graph inequalities if that variable is on the left side. So n is going to be what in relation to 8? So n, if I look at all my values, so 9, 10, 11, 12, 13, 14, 15, 16, 83, are all greater than 8. But I also have the ability, if I'm 8 years old, to be able to ride or to be able to sled by myself. So n is going to be greater than or equal to 8. That's the value for children who do not need to be accompanied by an adult. All right. So if we take a look at the other examples on the top of page 115, it says the length of a piece of wire L is longer than 20 feet. So my variable is going to be L, and it's going to be 20 feet. Again, I want to put the variable on the left side. So if it's longer than 20 feet, is it going to be less than, greater than, less than or equal to, greater than or equal to, or not equal to? Okay, so I'm taking a look at this. If it's longer than 20 feet, it's going to be greater than. Okay, the cost of the pizza C will cost at least $8. So the cost of my pizza is going to be at least $8. So if it's going to be at least $8, that tells me, notice I did that, it's going to be greater than. If it's $8, it's going to be $8 or more. So it's not $7. It's going to be, has to be greater than 8, but it also can be 8. So C is greater than or equal to 8. Okay. Henry's height h is less than 60 inches. So if I have a height that is less than 60 inches, this one's pretty simple. I just write the inequality that says less than. The number of students S is at most 30. So if I have 30 students, my value has to be less than 30, but it also can be 30. It can be equal to 30. So any value I put in for S, I'm not solving for S. It doesn't matter what I have. S can be any value under 30 to represent the number of students less than 30, or at most 30. Zoe's age, Z, is not 11 years old. So she is not 11 years old. So Z is not equal to 11. Okay, let's take a look at your guys' guided practice. It says, what is the difference between an equation with a variable and an inequality with a variable? Well, in equations, we talked about there is only one solution. The variable is only going to be one solution. In an inequality, I have many solutions that will make that inequality true. That's the difference between an equation and an inequality. So if I have x added to 5 equals 7, x can only be 2 to make that equation true. But if I have x is greater than 5, x could be 22, x could be 54, x could be 5, not 5, x could be 6. So I can have many solutions for my variable in an inequality, whereas in an equation, I can only have one solution. Okay. Number 2, a number n is greater than 22. So again, they tell me the variable. Variable is n. The number is 22. I'm always putting the variable on the left side. This will make your work so much simpler when you are graphing equalities. So get in the practice now of putting your variable on the left side. So going back, n is greater than. Again, it tells me the symbol I'm using. I'm using the greater than symbol. Okay? And then the value of v does not equal 2. So it's not equal to 2. And that's how I represent not equal. All right, so I'm going to do a couple more that are not part of your guided practice. just because I want to make sure that you understand what this needs to be. We're going to do, it says the number of students the bus holds, S, is less than 40. So S is less than 40. Okay. The next one that I have is the distance D is at least 10 miles. So D at least 10 miles. So D is going on the left because I always write my variable on the left when I'm doing inequalities. 10 is my value, is at least 10 miles. So it can't be less than because it's at least. So when I see this phrase right here, this phrase is going to mean greater than. It also is going to be equal to because it can be 10. So it's greater than or equal to. So when it's at least, I know that I'm going to be using my greater than symbol. It's possible I could be using my greater than or equal to symbol. Okay. The weight limit W on the bridge is 12 tons. So weight limit is 12 tons. So W is my variable. It has to be, it's not going to be equal to 12. It's not going to be not equal to 12, is 12 tons. So my value for W has to be less than 12. But I can have a truck that's 12 tons, drive across that bridge and be totally fine. So weight is going to be less than or equal to 12. Okay. Tim's age, T. So Tim's age, shame on me, let me capitalize that. Tim's age is not 21. Okay. So Tim, variable T, and 21, he is not 21. So it's not equal to. T is not equal to 21. The cost C is less than $45. So C is my variable, 45. The cost C is less than 45. It tells me the variable, or it tells me the inequality symbol that I'm going to use. Okay, so I hope this makes sense on how to write an inequality. One thing to remember is that an inequality has many solutions. And the other thing when you're writing your inequality, write the variable on the left side of the inequality. You're going to do this because it will make it very easy to graph the inequality, and I will show you that on the next math lesson. So you are going to go ahead and finish working on your independent practice and math practice and problem solving so you are able to describe a real world situation by writing inequalities.